All right, hello, Algebra 1 and Foundation students. We had a assessment over your last unit, so hopefully you've been working on that and got it finished. At the time that I'm making this video, I think I only have 3 or 4 of you that have submitted that test. Please let me know if you have questions. I'm not meaning for that to be a super hard assessment. I just want to see what you're able to figure out. So if you have questions on that test, please let me know. Use your notes, use the examples that we did on Delta Math. Go back and look at that stuff to help yourself out, okay? So with that being done, we're going to kind of move on to our next unit, which is writing equations of lines. And we're going to look at some other formulas that we use for lines. One of the ones that you already know is slope-intercept form, right? Slope-intercept form is y equals mx plus b, right? It's the first one, or the one we talked about in the last unit when we were graphing. And the m stands for our slope, and the b stands for our y-intercept, right? So we've got those two parts. Slope-intercept form is great and useful for graphing, right? Because when I graph a line, if I have the y-intercept and then the slope, it's pretty easy to graph. I can plot my y-intercept and then use the slope to get more points. So that's usually the most popular form we want it to be in if we want to graph the line. Okay, we've got a couple other forms that we use for lines. Point slope form is another one we use a lot, and this is the one that we'll use a whole lot in this unit. And that one looks like this. It's y minus y1 equals m times x minus x1, right? And in this one, the y and the x just stay as they are, but the m still stands for slope, just like in slope-intercept. And then the x and the y, the x1, and the y1 are coordinates of a point, right? So we've got a point that is x1, oops, sorry, got that wrong, x1, y1. And so in this equation, we use this a lot of times to make an equation of a line. If I know what the slope is and I know a point that the line goes through, then I can actually write the equation of that line. So point slope is useful for writing equations. And we'll say writing equations given certain info or information, right? And the last form is standard form of a line. We use this quite a bit less in Algebra 1 first semester. We'll use it a lot second semester in Algebra 1, or you'll see it a little bit more. And standard form is kind of what it means. It's the standard for a linear equation. So a lot of times when you're given a linear equation, you're given it in standard form, and then you have to change it to another one to do what you need with it. So standard form looks like this. Got ax plus by equals c. And that a, b, c, those are just numbers, right? So a, b, and c are integers, meaning they are not fractions or decimals. And then a and b can't both be 0. We talked about this a little bit in the last unit. We talked about how the ABC, like A and B, can't both be 0 if it's a linear equation. This was one of the ways we use to decide if something is a linear equation, is if we can put it in that form, right? Standard form is useful for finding x and y intercepts. We did that some in the last unit. So if you've got it in standard form for right now, for what we know so far, standard form is very helpful for finding x and y intercepts. Okay. And it's also useful for being able to tell if it's a linear equation. Okay, all right, so there's our kind of 3 equations we're going to use quite a bit. Let's start with just a little bit of kind of rearranging. So I've given you an equation here that's already in point slope form, right? So we've got this equation here, y minus 3 equals 2/5 times x plus 5. I want to change that equation into slope-intercept form, right? Slope-intercept form is y equals mx plus b. We did this a lot in the last unit, right? We wanted to put it into slope-intercept form so we could graph. So to get that one into slope-intercept, basically we just need to get y by itself. So we're going to take our y minus 3 equals 2/5 times x plus 5. And if I want to get that in slope-intercept form, I need to get this y over here to be completely by itself. So I need to get rid of that 3. But before I add 3 over to this other side, I need to get rid of those parentheses. So I'm going to start by distributing the 2/5. So that would make it y minus 3. 2/5 times x, well, that's just 2/5 x. And then 2/5 times 5, you want to kind of write that over here to the side. That could be 5 over 1, right? And if I multiply those, my 5s cross cancel, and I just end up with 2 over 1, which is just 2, right? So that'd be 2/5 x plus 2, because 2/5 times 5 is 2. Okay, now I can get rid of this 3. So I'm going to add 3 here, and I'm going to add it to its like term on the other side. So I'm going to add it to the 2, and I end up with y equals 2/5 x plus 5. And there is our slope-intercept form, right? So that is our slope-intercept form. Ta-da! Okay, then in this next one, now I want to change it to standard form, right? Now to change to standard form, I can go back and start with my point slope, but it's actually easier if I start with it in slope-intercept. So I'm going to go ahead and take this one that we just did, because that's still the same as that first point slope form. So y equals 2/5 x plus 5, right? And for standard form, I want x and y to be on the same side, right? Standard form is ax plus by equals c. So I want that ax and by to be on the left. Well, right now, I've got the y on the left side, but the x term is on the right side. So I'm going to start by moving this 2/5 x to be over on the left side, right? Okay, now I can't do y minus 2/5 x. Those aren't like terms, so I'm just going to write exactly what it says, right? However, in my standard form, notice that the x term is first and then the y term. So I'm going to put the x term first. So I'm going to write negative 2/5 x, and then I've got a positive y equals, our 2/5 x on that side is gone, so it's just 5, right? Okay, so now I've got my something x plus something y equals a constant, or my c. So it's mostly in standard form. The only catch is I don't want fractions when I have it in standard form, right? And I also, in standard form, I always want a to be positive. So we want our a to be positive. Okay, so that means I need to get rid of that fraction. Well, luckily, a couple units ago, before we were all home with e-learning, we learned how to kind of multiply an entire equation by something to get rid of the fractions, right? So if I want to get rid of that fraction, I need to multiply by a common denominator. So I'm going to multiply this whole equation by that 5. And then I'm also going to multiply by a negative 5. That way, when I do a negative times a negative here at the first term, I'll end up with a positive a. That's what we wanted over here, right? Okay, so multiplying by the 5, we're going to get rid of the fractions, right? Okay, so that means when I do negative 5, and if you want to put that over 1, if that helps, those 5s will cancel out, right? So negative 5 times negative 2/5. Well, a negative times a negative makes a positive. And then 5 times 2/5 would just leave me with 2x. Then I got to do negative 5 times positive y. So I would get negative 5y equals negative 5 times 5 will give me negative 25. Okay, that is our standard form. Now, we are not going to do a lot at all, really, with standard form in this unit. You might do a little bit of changing forms and such, but I am not going to focus on standard form much at all. So don't get too worried if you felt like that was a little bit harder than it should have been or something. I really just want you guys to see it for now. We'll do a lot more with it next year whether you're in Algebra 1 or Algebra 2. Okay, so now let's actually do what we're going to kind of spend a lot of time this unit doing, and this unit will be pretty short. We're going to write equations of lines given certain information, okay? So our first section here is I want to write the equation of a line if I am given the slope and the y-intercept, okay? So if I'm given slope and y-intercept, well, we know what those two things are, right? Slope is m, and y-intercept is our b, right? Okay, so now this says write the equation of a line in slope-intercept form. So you want to pay attention to what form do I need to write this equation in at the end. So I want to end up in slope-intercept form. So I want to end up y equals mx plus b, right? Now I am given the slope is 3, so that means that my m equals 3, and my y-intercept is 10, right? So that means my b equals 10. Or remember, you can think of the y-intercept as a point. That's a point of 0, 10, right? Okay, but either way, I have m and b. Now, if I want to put in slope-intercept form, the only two things I need are the slope and the y-intercept. Those are the two things I'm given, m and b, so I just plug them in. So I'm going to do y equals, my slope is 3, or my m is 3, so I get 3x plus b, well, b is 10, so plus 10. It's in slope-intercept form, I plug them in, and so I'm done. Those are the easiest problems you're going to see, right? You're given the slope, you're given the y-intercept, you just have to plug them into slope-intercept form, okay? Okay, now you might be asked to write the same kind of thing, but in the next one, now I want to write the equation of the line in point-slope form, right? So for point-slope form, that's our y minus y1 equals the slope times x minus x1. So for this one, we wanted a slope and a point, right? So I have my slope. So again, my m is 3. And then I have this y-intercept, right, which we know is b from the first way we did it. But this time I want that as a point. So now I want to think of this as a point. And the value of that, or the coordinates of that point, are at 0 for the x, and then the y-intercept is 10. Okay, so if I have that point now, that's like my x1, and this is my y1. Okay, so now I have all my stuff I need to plug in. So we're going to do y, leave the first y as y, minus your y1. So if I go over to my point, my y1 is 10, equals my slope, that's the m that comes next, right? So 3, and parentheses, x, this first x just stays x, minus x1. Well, over here, my x1 is 0, right? So I plug in the 0. There's our point slope form of that equation. So those two equations, y equals 3x plus 10, y minus 10 equals 3 times x minus 0, they're equivalent. They're the same thing. They're just both in point slope, or they're in different forms. Sorry, one's in slope-intercept, one's in point slope. Okay, one more with the same information. Now I want to put it in standard form, right? So the slope is 3, y-intercept is 10. So same information, m equals 3, and our b equals 10. Now notice on this one, I want my answer in standard form. That's ax plus by equals c. There is nothing in this problem that says a is this, b is this, and c is this, right? Also, please remember that a is not x, b is not y, m is not x. These are all different letters, right? I have a lot of people that will tell me this one, oh, well, 3 just goes next to the x, so it's 3x. And b looks like y, so I'll make it 10y. And then I'll just make c 0. You're making stuff up. That's not how you do this problem, okay? Standard form doesn't have any of that information in it. However, from a problem earlier with the same information, we started with slope-intercept form. So we know the equation of this line is y equals 3x plus 10. So on this problem, you have to start with a different equation. So maybe I start with slope-intercept form. And now I'm going to change it to standard form, right? So we've got to start one way and change it something else. So to get to standard form, I want to move my x term over to the left side. I'm going to subtract my 3x, and then I'm going to put them in order. So negative 3x positive y equals 10. And then the only other thing I need to fix there is I don't want that first term to be negative. So I'm going to multiply the whole thing by negative 1. So then I'll get positive 3x minus y equals negative 10. So there's our standard form of the equation. Okay. Okay. There's our three different forms, all the same line. If I put those all in Desmos, they would all graph the same line. They're just in different forms. All right, so let's try some different information. This time, we're going to be given a slope and a point, right? So slope, remember, is our m. A point is x1 and y1, right? Yeah, dog's barking at me. Okay. All right, so this one says, write the equation of a line in slope-intercept form. So that's how we want to end our equation, right? Y equals mx plus b is where we want to end up. And we are given the slope is negative 6. So our m equals negative 6. And we're given a point. It passes through the point 3, negative 1. So this is our point, right? So that means this is our x1 and our y1. Okay. Sorry, guys. Dogs are barking. I don't know if you can hear that, but they're noisy. I'm dog sitting for someone. I'm not usually a dog person, but he's here. He leaves tomorrow. Okay, so now I want to put this in slope-intercept form, but I know the slope. I don't know the y-intercept, right? I'm given this point, but this is not the y-intercept. It's just a point on the line. So don't confuse those two things, right? So anytime you are given a slope and a point, we're going to use point slope formula. You see how that's in the name of the formula? Kind of nice, right? Point slope form. That means if I have a point and a slope, I should start there. So I can't start in slope intercept form, but I can start with point slope form, which remember it looks like y minus y1 equals m times x minus x1. All right, so then we're going to plug in our information here. I'm going to do y minus my y1 over here for my point is negative 1. So y minus negative 1 equals my slope is negative 6 times x, leave that one as x, minus my x1 from my point is 3. Okay? All right, then we can simplify a little bit. If I have y minus negative 1 minus a negative, that's the same thing as adding a positive, right? Subtracting is the same as adding the opposite. So I'm going to make this y plus 1, and then I'm going to distribute my negative 6. So negative 6x, and then negative 6 times negative 3 would make positive 18. Then I want to get this in slope-intercept form, right? So I want to get y by itself. So I'm going to subtract 1 on each side, and that will leave us with y equals negative 6x, and then 18 minus 1 is 17. So our slope-intercept form of the line is y equals negative 6x plus 17. Okay, so even though it says I want slope-intercept form, I had to start with point slope form because of the information I was given. Okay, all right, next problem. Write the equation of a line in standard form this time. And you know what? I'm going to change that. Let's make it slope-intercept. Let's just practice that again. Okay, so write the equation of line in slope-intercept form whose slope is 2/3 and passes through the point negative 6, 5. If you'd like to, this might be a good point to like pause the video, try this problem on your own, and then come back and see if you get it right. If not, that's fine. Just keep watching. Okay, so again, I want to end up in slope-intercept form, but I'm starting with a slope and a point, right? If I just have a slope and a point, I want to use point slope form. So my m is going to be 2/3, and then my x1 is negative 6, my y1 is 5. Okay, so we've got our y minus y1 equals m times x minus x1. Plug everything in. So first one stays y, minus my y1 was 5 equals my m is 2/3 times x minus my x value is negative 6. Okay, Okay, we can simplify there a little bit. I'm going to make this y minus 5, and then my 2/3. That x minus negative 6, I'm going to rewrite that as x plus 6. And then I need to distribute in this 2/3, right? So I'll get y minus 5. 2/3 times x, that's 2/3 x. And then if you have to, write this out as a separate problem. So 2/3 times 6, I can put 6 over 1. I can cross cancel the 3 and the 6 there. That becomes a 1, that becomes a 2. So then we get 2 times 2 is 4 over 1. So that's just 4, right? So it'll be 2/3 x plus 4. Okay, then last, we want to put it in slope-intercept form. So I want to get y by itself. So I'm going to add 5 on both sides. I get y equals 2/3 x plus 9. And there is our slope-intercept form. Okay. All right, a couple examples on those. We're going to try just like 1 or 2 of these today on your homework. It's going to be a very short homework because I just want you to get the very beginnings of these problems. Okay. I just realized that my kids are really loud outside as well. They're throwing water balloons at each other. So if you can hear them, I'm sorry if they're distracting. Try your best to pay attention. Okay, so next couple here. We want to write the equation of a line that has a slope of 0 and passes through the point -3, 7. Okay, now, anytime you see these, and notice the next one, that one says a slope of undefined and passes through the point. These are special. These are really fast if you learn how to recognize them. If I have a slope of 0, right, m equals 0, think to yourself right away, if my slope is 0, what kind of line is that? This is your horizontal and vertical lines, right? So if I have a slope of 0, you can think of that slope, that would be like 0 over some number. You can make up any number you want. Let's say it's 3. 0 divided by no matter what is always going to be 0, right? So this means no rise, because it's a 0 on top, over some sort of run. We're only running. We're not rising, right? If I'm not rising, then that means, that this is a horizontal line, right? There's no rise. We're only running. You can't run straight up. You have to run horizontally, right? I know you can run at a diagonal, but use that to help you, right? So we're only going side to side. So it's a horizontal line. The equation of a horizontal line is always y equals something, right? And if it has to go through this point, well, look at what the y value is. It's -7. That means the y value will always be -7, right? I have to pick points that will always be or always make a horizontal line. So then all you have to do is say that y equals -7. There's my equation. Ta-da! Okay, so if you can look at the slope, you just have to figure out if it's 0 or undefined, is it horizontal or vertical, and then you can go straight to your equation and your that's y equals. The hardest part is remembering that horizontal is y equals and vertical is x equals. Okay, so using that same method then, if my slope is undefined, right, my m equals undefined, that would mean that I have some number, whatever it is, over 0. So this means I'm going to rise, but there's no run. I'm not moving side to side. I'm only moving up and down. So this is a vertical line, right? And the equation of a vertical line is always x equals something, okay? So then I can go to my point, find my x value, and just say x equals 9. Ta-da! There's my equations, okay? All right, one other type of problem here. The last set is if I am given 2 points, okay? So in this situation, again, I want to write the equation of a line, and I want to write it in slope-intercept form. This time, though, I'm just given that it has an x-intercept of 5 and a y-intercept of -10, right? Now, an x-intercept and a y-intercept, those are points, right? I can write this as 5, 0, and I can write this as 0, -10. So if I'm given those 2 points, now I want to write the equation of the line. Now, we've done a few where like we were given the slope and a point, or we were given a slope and the y-intercept. But in this case, we're just given the 2 points. What's missing? Slope, right? But in the last unit, we learned how to calculate slope. So if I want to find the slope of this line, I use the formula y2 minus y1 over x2 minus x1. So now we can plug those in, right? And you can label these. This is my x1, y1. This is my x2, y2. Plug in those numbers. So y2 is negative 10 minus y1 is 0. x2 was 0 and x1 is 5. All right, negative 10 minus 0, that's negative 10. And 0 minus 5 would be negative 5. And I can simplify that. Negative 10 divided by negative 5 is 2. All right, so that means that our slope is 2. Okay, now that I have my slope, I can write the equation of my line, right? And I've got my slope, and then also remember up here, we were given the y-intercept. That's our b, right? So if I know m and I know b, I can go straight to slope-intercept form. Slope-intercept form is y equals mx plus b, right? We have those two things, so we plug them in. So y equals, our slope is 2 times x plus b, which is our y-intercept, so that'd be negative 10. So actually, I'm going to write minus 10. And there's the equation of our line. Okay. All right. One more example just like that one, and we'll be done here. Okay, so again, I want the equation of the line, and again, I'm not going to do standard. Let's do slope-intercept. And this time, again, we pass through these 2 points. Now, this time, we're not given x-intercept and y-intercept, right? But we're going to start the same way. First thing we need to do is we need to find our slope. So we're going to do our y2 minus y1 over x2 minus x1. Okay, and if you want, I find it helps a lot to label your points. So x1, y1, x2, y2. So we'll do 2 minus negative 3. And on the bottom, the x's, I'm going to do 4 minus 7. 2 minus negative 3, that's like 2 plus 3, so I get 5. And on the bottom, 4 minus 7, that's negative 3. So that means that our slope is negative 3/5, right? Okay, so then this time, I don't know my y-intercept. I can't go straight to slope-intercept form, right? So if I can't go straight to slope-intercept form, but I do have a slope and I have a point, right? I have my x1, y1. So instead, we're going to use point-slope form because I have a point and I have a slope. So we're going to go to our y minus y1. Actually, I'm going to put that over here. So y minus y1 equals m times x minus x1. And plug your stuff in, right? So y minus y1. Now, it actually doesn't matter. You can pick either point here. It's totally up to you. I'm going to use the one that I went ahead and labeled x1 and y1, but you could use x2 and y2. It doesn't matter which one. So y minus, I'm going to plug in negative 3 for my y1 equals my m is negative 3/5. And then x minus my x1 was 7, right? Okay, so then let's see, we can simplify that a bit and say y minus negative 3 is y plus 3 equals negative 3/5 x. And again, if you need to write it out, negative 3/5 times negative 7 and put that over 1. Well, a negative times a negative is going to give us a positive. Nothing I can cancel there, so I'll get 21 over 5, right? Now, if you don't want to deal with the fractions here, remember you know how to get rid of those, right? So if I wanted to, I could multiply everything here by 5 to get rid of the fractions, if you'd rather do that. So then I get 5y plus 15 equals negative 3x plus 21. And hey, now I don't have to mess with the fractions. I want to get y by itself, so I'm going to subtract 15 over to this side. And that'll give us 5y equals negative 3x. 21 minus 15, that is, what is that, 6, right? positive 6. And then I got to divide everything by 5 to get y by itself. So we get y equals a negative 3/5 x plus 6/5. Ta-da! And it is okay to get lots of fractions here. It's totally fine, right? It's always okay to get fractions. I won't do a lot of fractions with you today on your homework. I just want you to practice the basics. But eventually you will see lots of fractions in these problems in Algebra 2 or Algebra 1 next year. Okay? All right, that was a lot. There's a lot there. I'm going to make a very short homework for you today on Delta Math. I just want you to do like one of each type of problem, and that's it. So look for just trying it. Go back and use the notes, right? Like look at the notes and follow that process exactly. I just want you to try one or two and try to do them right after you watch these notes. That way it kind of sticks in your brain. And then our next class, we'll do some more practice with these where you're doing a few more problems. It's more like a homework day. Okay? All right. You guys have a good day. I will see you later or next year, next school year, I guess, in the fall. Hopefully soon.